How to find the zeros of a polynomial? Let's go. So the zeros of a polynomial are where the polynomial crosses the x-axis. So essentially they are the x-intercepts of the polynomial. So when f of x equals 0, then we can find the zeros of the polynomial function. So in this case, in our problem, let's set each of those equal to 0. X plus 3 whole squared equal to 0, 2x minus 1 equal to 0, and x plus 1 whole cubed equal to 0. Okay, when we do that, let's take a look at the multiplicity. So when you have for the first one, x plus 3 is being multiplied twice, x plus 3 times x plus 3. So the multiplicity is 2. For the second one, 2x minus 1 is just once. So multiplicity is 1. And for the last one, x plus 1 times x plus 1 times x plus 1. So it's whole cube, so multiplicity is 3. So let's solve for it. X plus 3 whole squared, square root on both sides, you get x plus 3 is 0. Take the 3 to the other side, x equals negative 3. That's our first x-intercept. For the next one, 2x minus 1 equals 0. To take the negative 1 to the other side, divide both sides by 2, we get x equals half. So that's our next x-intercept. The last one is x plus 1 whole cubed equals 0. So cube root on both sides, and we get x plus 1 is 0. Take the 1 to the other side, x is negative. So those are zeros of a polynomial. Negative 3, negative 1, and half are the zeros, are the x values where our graph will intersect the x-axis. Okay, so I have the graph here, and let's take a look at those three different points: negative 3, negative 1, and half. So the total behavior of this graph, in order to graph this, is to take a look at the total number of x that are present. So x plus 3, there are 2, the x squared, 2x minus 1, there's a single x, and x plus 1 whole cube, there are 3 cube root. So 3 plus 1 plus 2, that gives a total number of 6 x to the power of 6. So the behavior is similar to x squared. So it will be going up on the left and going up on the right. Okay, so that's what I started here on the left. Is I started going up on the left, and then at negative 3, you see it's like a quadratic behavior because it's whole squared. So it's going to touch the negative 3 and rebound back like a quadratic equation. Okay, at x equals negative 1, it's like a cubic function. So we're going to go dip and flatten and then go back. So because it's x plus 1 whole cubed, it behaves like a cubic function. And then at x equals half, it's basically a linear function. So it's going to go straight through the graph. So, and look, and I plotted it using Desmos. So you see the similar type of behavior at x equals negative 3, it's a quadratic, and then a cubic at x equals negative 1 and x equals half, it's like a linear. I hope you enjoyed this video. Please let me know if you have any questions. Thank you very much for watching. Bye-bye.